Hi everyone, so this is an introduction to selection sort, and selection sort is basically a simple sorting algorithm. It's one of the many different sorting algorithms, but it tends to be more on the simple side. So what is selection sort? So selection sort is a comparison-based sorting algorithm. The way it works is we repeatedly select the smallest element from the unsorted part of the list, and we're going to swap it with the first unsorted element in our list. It's very simple, but it's not the most efficient for some of the more larger data sets just because it takes a much longer time than some of the other sorting algorithms, which is something we'll look at in a little bit. So how does selection sort work? So the first step is to find the minimum. We look through the unsorted portion of the list to find the smallest element. The second step is we swap the element that we found with the first element of the unsorted portion. The third step is to repeat this process. We continue to look further into the sorted and unsorted portions of the list. And the fourth step is to just continue this process until our entire list is sorted. So this might be a little confusing so far, so let's go over an example. So this is the list that we are starting with. These are the current elements, and our goal is to sort it using selection sort. So we're going to start at 29, and we're going to look at all the elements after 29, which is the unsorted portion of the list, and find the minimum. Hopefully you can see that 8 is the smallest element in the unsorted part of the list. So now what we're going to do is we're going to swap the 29 with the 8. So as you can see, we've swapped the 8 and the 29, and the 8 is in its correct position. So now we have 8, which is in the sorted portion of the list. So now we're going to look at the next element in our unsorted portion, which is 10. Now we're going to look to the right of 10. There is not any element that is smaller than 10, which means 10 is also in its right spot, and we don't need to do any swapping. So we're going to move on to the next element. The next element is 14. We're going to look to the right of 14 and look for any element that is smaller than 14. Hopefully you can see that 13 is the smallest element. And so once again, we are going to perform a swap, and we are going to swap the 14 and the 13. So now we have 8, 10, and 13 in our sorted portion. So now we're going to start looking from 37. So we're going to look to the right of 37 and find the smallest element. Hopefully you're getting the hang of this and you see 14 is the smallest element. So once again, we're going to perform our swap. And then we are in our second last element, and we are going to look to the right. And since there's only one element, which is 29, we're just going to swap them. And now we have a sorted list. So that's basically how you perform selection sort. You can do it on a very small list, a very big list. It really doesn't matter. It's a very simple sorting algorithm. You just perform it using finding the minimum element and continuing to swap until you're done. So now we're going to briefly look at the pseudocode. I'm not going to get into too much detail, but essentially how this works is we have an outer loop, which loops through one index at a time. We set our current minimum index to be the current element that we're on, and then we look to the right of the list as we were before, and we look to see if we have any element that is smaller than our current minimum. If we do, we switch our minimum index, and then we perform a swap. We do this for every element as we go forward until we have finished swapping our list. Finally, we're just going to quickly go over the time complexity. So in terms of selection sort, the best, worst, and average time complexities are all O of n squared. This is because regardless of what our list looks like, we're going to be following the same exact procedure. So if we go back to the pseudocode, as you can see, regardless of what our list looks like, we don't do any checks to see if the list is already sorted. We don't do any form of checks when we're starting or ending. We do the same exact steps regardless. So even if we started with an entirely sorted list, we would still loop through each element at a time and then look to the right of it and loop through each element at a time as well, which is where we get the O of n squared. Later on, we'll be looking at some of the other sorting algorithms such as bubble sort, insertion sort, and a couple more, and we'll see that their best, average, and worst case time complexity are usually different, but in terms of selection sort, they are always the same.